In this video, we are going to learn Newton's second law of motion. In last video, we have enjoyed Newton's first law. Before learning this law, second law of motion, we will enjoy this experiment and we will learn some concepts, because after learning this concept and this experiment, you will easily understand Newton's second law of motion. Okay, let's see what is net force, what is mass, what is acceleration, step by step. Okay, for net force, I have drawn some objects here which are identical objects. You can take identical or different objects, no problem, but I have applied same forces on each object. Then we will get net force for first, second, third are 5 Newton, because I have applied 5 Newton to each object. But suppose I have applied one more force to first object and it is in opposite direction. Suppose it is 3 Newton. Suppose I have applied 3 Newton to second but same direction, 3 Newton. And suppose I have applied 5 Newton in opposite direction. Then for these conditions, we will get different net force. For first case, we will get total or resultant or net force as 2 Newton. For this case, we will get total resultant or net force as 8 Newton. And for this case, we will get 0 Newton. How we will get different effect? Because there is overall effect because of direction. Because force is vector quantity, it possesses direction, and that's why you have to consider direction also. For first case, suppose 5 Newton, which is applied in right direction, is taken as positive. You can take positive, negative, no problem, because you can take convention. I have taken convention right direction as positive because we have studied in school days that right is positive, left is negative from geometry. Then 5 Newton is taken as positive, then 3 Newton is applied in left direction is taken as negative. Means 5 minus 3 will get 2 Newton. In this case, 5 Newton and 3 Newton both are applying same direction towards right direction. Both can be treated as positive, means 5 plus 3 will get 8 Newton. In last case, both forces are equal in magnitude but opposite in direction. That's why this 5 Newton get cancelled with this 5 because it is treated as negative. Therefore, total result will be 0 Newton. Means this body having net force 0. It will not move. But these bodies can be moved. I think you got what is net force. For net force, I have taken symbol F. Whatever the force F is represented as net force, because that net force concept is included in second law. Now, these two are having different masses, because this trolley, these are actually 3 trolleys are I have drawn, because this second and third trolley we have studied first. Because this trolley is empty, this trolley is having some material, that's why its mass is slightly more. But forces applied to net forces, remember, net forces applied are same. If both forces are same, then you will get same effect or different effect. In this case, effect is acceleration. What is acceleration? You can accelerate your motorcycle or scooter. Means you are increasing your velocity. Acceleration is nothing but change in velocity per unit time. In which time? Time duration in which force is applied. That is time duration. During that time, velocity is continuously increasing. If velocity is increasing, then you can say it is accelerating. In this case, we get A1 acceleration, in this case A2 acceleration. Now why different acceleration? Because of difference in mass. Difference in mass, but I have represented one word which we have included in our first video, inertia, and actually we have studied. What is inertia? It is name given by Galileo to property. Which property? To oppose. To what? To change its state. It means that material state. Now what is the material state? Now they are rest condition, that is state. Means velocity is constant. It is 0 meter per second, but it is constant. But because of these forces, we are changing their velocities. But they are opposing. Who will oppose more? Who will oppose more? Having more inertia. But inertia depends on mass. Remember, inertia is property and exact reason of inertia is still unknown to physics. But inertia can be measured by measuring mass. Therefore, you can say mass is the one way to measure inertia. In reality, inertia is unknown till date. You are observing this video today, but inertia is exactly what is the reason still unknown. Okay. In future, we will get known about inertia. Okay. Means we are going to measure mass. This mass is more than this one. That's why it opposes more. As it opposes more, means its velocity is increasing slightly less than this one. Means we get acceleration 2 is slightly less. You can write acceleration depends on mass. As mass changes, acceleration changes for same mass. Means acceleration depends on mass. Acceleration depends on mass. But mathematical form, in mathematical form we can write acceleration is directly proportional to mass or inversely proportional to mass. Just we have studied, as mass increases, acceleration decreases, means it is inversely proportional. Means acceleration is inversely proportional to mass. These are the symbol for mass and acceleration. Okay, this is first effect we got. Now second effect. What is the second effect? Suppose we are applying different forces for same mass. That's why I have taken this first trolley. Suppose this force for second trolley and force for this one is suppose F dash, that is different. You can take any symbol. If F dash is more than F, then what you will say? It will accelerate more than this one. You can say it is A3. In this case, A3 is greater than A1 because F dash is greater than F. A3 is greater than A1 because F dash is greater than F. Means this force and acceleration having one relation. As force is more, acceleration is more. In symbolic form, you can write acceleration is directly proportional to force. This is second effect. Means from simple experiment, we got two effects. Combining these two effects, we can write in mathematical form as acceleration is directly proportional to F upon m. You can observe these two form and this form. Now, in statement form, we can write or we can say acceleration of body is directly proportional to net force applied on that body and inversely proportional to mass of that body. This is the Newton's second law in simple form. Okay. Now, in next video, we will see Newton's third law, which is also very interesting, but you may get confused by asking some questions. Okay, we will learn it. And after that video, we will learn first, second, third law combinedly. And in fact, we can derive first law from second law. We can derive third law from second law. Then question is, why Newton developed 3 laws instead of only one law, that is second law? That we will also learn. Okay.